Hey guys, welcome back to this platform. In this case, what we are going to do is to focus on the hydraulic accumulators. We just want to talk about the hydraulic accumulators in general. Just the basic part, what you need, as we are going to have questions or as a whole, like the hydraulics, everything on hydraulics. I think this is the last part of our introduction, which is the hydraulic accumulators. All right. So the hydraulic accumulators, they are actually like this is a pressure a storage reservoir, like it's a pressure storage reservoir. That is the external source. In this case, if you consider this is the one that you're given, that it is simply a pressure storage reservoir in this case. So considering the fig that we have here, we've got a basic diagram of an accumulator. So the external source, it holds a non-compressible hydraulic fluid under a certain pressure, all right? So we've got the inlet from the pump, that is inlet that it holds at a certain pressure, all right? Then this is our outlet, all right? So what happens is that this is the when you're talking about the pressure that is being compressed, the non-compressible pressure that is being applied, this pressure can be used on demand later. It can actually be used later on, right? Because it is actually a type of energy storage device. So this is a storage device that we have. So it is going to be used later on, right? So this is what we have. The external source can be weight, like what we have this year. We can use a weight, we can use a compressed gas, we can use a spring. All right. So that is what we can have in the consideration. And accumulators usually have got a cylindrical chamber, which has got a piston inside. Right. So in this case, we've got our piston that is inside of the cylindrical chamber. This piston is pressurized using one of the following methods. The methods to pressurize this piston can be from the spring loaded. It can be spring loaded. It can be a calculated weight. So it depends with what you have. It can be the piston is evenly, and it can be taken as pneumatical, like from pneumatical compression, all right, from that pneumatic part of our pressure that is being applied. Remember, we've got the oil that is there, all right? Remember your pneumatics, guys, okay? So we have got this part of the pressure, because we're talking about the piston in this case being pressurized. We have got the pressure here being applied. We've got the applied pressure here, the applied pressure to the piston. So that is the one that we have. So that is, I think, what we have. And the types, can consider the types. We can talk about the ballast type accumulator. These are the types of the accumulators. We can talk about the ballast type. We can talk about the spring loaded. We can talk of the spring loaded accumulator. We can talk of the compressed gas accumulator. All right, we can have it as a compressed gas accumulator, which can further on be given as a bladder type, a diaphragm type, a piston, or a metal bellow. All right, so that's where we can have this, and we also the functions to provide a reserve of power, supply of oil, provide of sufficient power to complete one or more cycles of operation, help to reduce pump ripple. There are so many functions that we can have on our accumulator. All right. So before we have the questions that we are going to talk about, there are some of the formulas that are necessary as you are going to be having these accumulators. Talk of volume, just like when we talked about when we are talking about a simple hydraulic press, we have got a volume there. Still, we've got the same thing in this case. We are going to talk about the volume, which is simply from the area times the distance, which is in this case pi d squared over 4 times the stroke length, which is our distance from the stroke. That is the stroke length. And I said, when you are given a number of strokes, you are going to multiply this by the given number of strokes that you be given. That is provided that you have got what? You have got the number of what? You have got the number of strokes. You are given the number of strokes. on that condition, you can use this formula with N for the what? For the volume. This, we talked about this. And if we are given the number of strokes, this is going to be number of strokes, and they'll be taken per second. If you check from our previous case, we were just given the strokes as just normal strokes. But this, when given the number of strokes, it shall be volume per second. The moment you are given number of strokes per second, therefore it implies that your volume is going to be calculated as volume per second, which is in what? Cubic meters per second. So it depends with what you are given. We shall talk about that depending with the questions that we shall be given or that you'll be given. Also, the issue of pressure. All right, we talked about this from our previous case, that the pressure can simply be taken from force over the area, which is measured in Pascal. Remember, our pressure is measured in Pascals. Then also, we can take from pressure volume. I mean, from the density, if you're given, density, that is rho GH. Pressure can be given as rho GH, all right? Also, we can talk of the gravity, the W, which is the weight here, which is given by mass times gravitational acceleration, which is measured in newtons. So these are some of the things that you need. We talked about this, the pressure of at a certain depth, which is rho GH, still measured in pascals, just like the previous case, right? So I think that's it. Then we can talk of maybe given a condition that we've got a ram, or on a condition of considering the ram, because here we've got the sliding ram in this case. So taking the length of the ram as L or as H, you can take as L or as H, depending with what you want on your simplification, all right? So on the accumulator, I'm just going to use the ram distance as what? As L to represent what? The ram distance. They are going also to need you to understand about the volume, which is the volume of the machine. So the volume of the machine is given as pi d squared over 4 times the ram distance. So you can even use H as the one that we've been using before. It's fine. You can use that, right? So that is the D is the diameter of the ram. This is taken from the ram, all right? This is diameter. That is ram diameter in this case, which is measured in what? In meters. And this is the distance moved by the ram, which is the ram distance. All right. So that's what you can have there. And also the important things, work done, power, efficiency. Yeah, you can talk about that. Work done. You can talk about this also. The work done, the power, and also the efficiency. All right, efficiency. At the same time, including efficiency. So you see that, remember, work done can be taken from force times distance. So we talked about this formula before, force times distance, which is the stroke length. So if you want power, I said power is simply work done per second. So it means if it is work done per second, we can take force over time. All right. I mean, the work done over time, because in order for us to have what? To have per second. So it means it's simply the work done over the time, which is the power, the work done per second. All right. Remember, what work done is power is work done per second. And also, if you have got this, you can have efficiency, which is the output over the input. So let's just write as output over input, because as long it is output over, it can be output force, can be output power, whatever that you have, as long it is taken from the output over the input. That is for the what? For the efficiency. It is very, very important for you to also understand this on the efficiency. Then also there's this question, and I have been talking about this question, and most of us, I think, you've been asking, where is it coming from, or this and that, but I think this is the right time to answer you that question. I've been talking about a question where you'll be given to calculate the additional mass required to act as a weight to obtain the required pressure. there will be a certain pressure given and you want the additional mass. So in order for you to obtain or to calculate this additional mass in this case, which I'm just going to write as MAD like this, MAD like additional mass. So the additional mass is simply taken from the total mass because the total mass, what it does, it consists of the mass that is on the RAM, the mass of the RAM, plus the additional mass that is required to act as a what? As a weight to obtain the required pressure. So meaning to say this additional mass is supposed to maintain or for us to obtain a certain required pressure on our machine. So talking from that pressure, we know that the pressure is equal to the force over the area. All right, that is our pressure. So if we find this force, because the force is the one that carries the mass, if we cross multiply this, we are going to have force is equal to pressure times area, whereby force consists of the mass. So it's the total mass times the gravitational. So that's where the total mass is found, from mass times gravitational acceleration, because it must contain this pressure. So in order for us to have a mass required to act as a weight to obtain a required to obtain a required pressure, we must obtain this pressure. So the additional mass is already there, it's added. So meaning to say the mass that is inside here is, there are two masses that we have, the additional and the mass of the RAM together, they are inside this. All right, so this is equal to PA. So we can calculate this by dividing by the gravitational acceleration. So it follows that the total mass is going to be taken from the pressure times the area over the gravitational acceleration. And we know that area is simply taken from pi d squared over 4. So this is pi d squared over 4, depending with where you are given the full information. But that is the idea in this case. If you're taken from the RAM, it is going to be pi d squared, depending with what you're given. But this one is going to be of the RAM, sorry, because it's not going to like depend, because we are dealing with additional mass to the RAM. So it's going to be pi d squared over what? Over 4 like this, all right? That is the area that we have. So meaning to say from the additional, from the total mass that we have, we can calculate this additional mass because of the formula that we have stated that the additional mass plus the mass of the RAM gives us MT. So it follows that the additional mass is going to be, if we transpose this, it is going to be MT minus M from the RAM. So that is the total mass minus the mass of what? Of the RAM. This is our additional mass. So meaning to say, if I have got the total mass from here and given the mass of the RAM, I can be able to calculate what? To calculate the additional mass that is going to act, that is required to act as a weight, all right, to obtain the required pressure, a certain pressure. So that is the idea there, all right? So you can play around with this formula to find this. And also with this total mass here that we have, they can ask you to calculate the work done. Since we now have the total mass, so the work done is taken from the total mass, right? Remember, work done, I talked about this. I said work done is force times distance, all right? Since it is force times distance, which is force times taking it from the RAM, it is going to be force times the distance moved by the RAM, all right? So that will be force times the distance moved by the RAM. And I said the distance moved by the RAM, I'm going to write as L. Yes, you can use H, right? Or you can just use L for accumulators. But this F, remember, is the one that we said force is total mass times what? Gravitational acceleration. So it is going to be given as the total mass times the gravitational acceleration times what? Times the length, which is the distance moved by the height. So this can give us the work done, which is measured in what? Which is measured in joules, all right? So once you have got the work done, remember we can calculate power, because I said power is simply work done per second. So if it is work done per second, it's simply this work done over time in seconds. That's power. That's power for you. All right. So these are the formulas I think that are important for now. More to come because this is not like the end of it. We're going to talk about this later on as we revise question papers and so forth. But before that, we just have 2 questions that we're going to consider. So from what I've discussed with you, I want you to go through this and answer question 1. Question 2, name 3 types of hydraulic accumulators used in industry. So that's where we can talk about the weight-loaded piston type, the diaphragm or the bladder type, the spring type, the hydropneumatic piston type. There are so many. 6 functions of an accumulator. I also mentioned about the functions of accumulators. So what I want you to do is to go through the part that I explained to provide a reserve of a power. We talk about supply of oil for high transient flow demands, provide sufficient power to complete 1 or more cycles of operation of the equipment when the pump does not work, help to reduce pump ripple. It can also act as a hydraulic shock absorber. It may be used as primary power source for small hydraulic systems. So there are so many. I just want you to go through and list them and also check through the questions. I also listed these ones. I want us to focus on this question. This is the major question that you might be given when working with hydraulic accumulators. We have talked about this type of a question before, but now it can make sense after we have talked about the formulas and how to connect your formulas. We are given that it's a mass-loaded accumulator. Take note, it's a mass-loaded accumulator, and it has a diameter of 400 millimeters and a mass of. So this information is taken from the RAM. All right, this part, the mass-loaded, where do you put the load? On the RAM. All right, the load is on the RAM. So this is the diameter of the RAM in this case. So that's the diameter of the RAM. It's 400 millimeters divided by 1,000. That's 0.4 meters. We have got the mass of the RAM also. That is the mass of the RAM that you are given there, which is 600 kilograms. That's how we answer this question. The machine, it serves required, okay, the machine, it serves, that is the machine that it serves. It requires a pressure of, so it is going to need a pressure of 1,2. So this is the pressure required, 1,2 megapascal. It is going to need this pressure. So the RAM, it moves through a distance of 350. So this is L or H. You can write L or H, which is 0.35 if you divide by 1,000. In 6 seconds, we are also given the time frame, which is 6 seconds during the working stroke of the machine. Calculate A, the additional mass required to act as a weight to obtain the required hydraulic pressure. So this is the one that I was talking about here, to say the additional mass can be taken if we calculate first the total mass. So I'm not going to talk about how to interpret, how to manipulate this, because already we have manipulated our formula. It is the same thing. So I'm going to start from this part here where we have got the total mass already. Remember, we said the formula for the total mass after manipulating this formula, the total mass is going to be given as the pressure times the area over the gravitational acceleration, where the area is simply pi d squared over 4. So this is going to be the pressure. We have got the pressure 1,2 megapascal 10 to the exponent of 6 times the area. That's pi times d squared, which is the diameter of the RAM, 0.4 squared over 4 like this. So this is going to give us what? All right, this is going to give us, this is our PA, pressure times area, over G, which is our gravitational acceleration, is taken as 9.8 meters per square second. Or you can use 9.81. It's like this instruction was 9.81 or something. All right. Yes, it was, is the instruction. And also the other thing, the instruction of this is, guys, this is a textbook, this one. So they said use pi to be 3.14 there, 3.142. So you're going to take your pi here as 3.142. But under exam condition, you don't consider this. You just use your pi on your calculator as it is. And also in this textbook that I'm using, they were using their G as 9.81. But under exam condition, you're going to take your G as 9.8. So this will give us the total mass which is something like 15,373.70031 kilograms. That is the total mass. But like I said, in order for you to have the additional mass is therefore taken as what? The total mass minus the mass of the what? The mass of the RAM. So from the total mass that we calculated here, it therefore follows that the additional mass is equal to the total mass minus the mass of what? Of the RAM. So here we are simply subtracting because we have the total mass that we calculated in this case, which is this value. We got 15,373.70031 minus the mass of the RAM. The RAM has got a mass of what? 600 kilograms. You subtract these two, you are going to obtain the additional mass to serve that pressure. All right, so that's 14,773.7. All right, kilograms. That is our additional mass. All right, that is the additional mass. Take note about this. You have to calculate the total mass from the pressure, the formula of pressure here. We manipulated this, if you still remember, then you have your MT there. All right, anyways, let us check the other part. Then on this part, they need us to calculate the work done by the RAM during the working stroke of the machine it serves. It is supposed to serve this machine, which is applied at a pressure of 1.2. And when it is serving this, the total mass is the one that we calculated. So you can calculate what? The work done. Remember, work done, force times distance. We talked about this here, which is going to end as what? Work done is force times distance. So it's going to be total mass times gravitational acceleration times the distance moved by the RAM. All right, so that is the formula that we are going to take for the what? For the work done. So I'm just going to calculate it here as our B. So the total or the work done is going to be given as the total force times the RAM distance, the distance moved by the RAM. So the total force is the one that we take from the total mass times the gravitational acceleration times the distance moved by the RAM. The total mass in this case from our calculation gave us 15,000. It was 15,373.70031. Okay, we can just even take it as a 7 because this 00 does not even affect anything, these ones. All right, just take a 0 there too, like this, times the gravitational acceleration, 9,81 times the RAM distance L. Remember our RAM distance here, we're given L as what? 0,35. The distance moved by the RAM, that's 0,35. So this can actually help us to calculate the work done. And the work done at this moment is going to give us something like 52,785,598 5 something like that, 5989. Is that so? 59895, something like that, right? So you can even divide by 1,000. So it's going to be 52,78. This 5 is going to change this into 6. That will be kilojoules. All right, remember work done is measured in joules. So this will be in kilojoules, okay? That's work done for you, okay? That's it. Force times distance, just like that. All right, then the power transmitted. Now we need the power transmitted by the RAM. Take note, transmitted by what? By the RAM. During the working stroke of the machine it serves. So remember I said power is simply work done per second. That is power here. It's work done per second. So to have work done per second, it simply means work done over time. So that's power for you. So power is simply work done over time. So that's C. Power is equal to the work done over the time taken. That is work done per second. So the work done, we have got our work done here. That's 52,786 times 10 to the exponent of 3. That is kilojoules over the time. Do you have the time? Yes, we are given the time. Remember here, our time was 6 seconds. In the time frame, 6 seconds. In 6 seconds, what is going to be your your power in 6 seconds. So we divide by the time in seconds because it's supposed to be work done per second, joules per second. So that is going to give us something like 8797,666 like that in watts. So if you want to convert to kilowatts, gonna divide by 1,000. That is going to be 8,798. This is gonna change into 8. That is in kilowatts. Remember, we have divided by 1,000. So your answer is now in kilowatts, or you can just write it like this: 8,797,666 in what? In watts. Okay, that is how your questions are given as. So we've got more questions to come, but let us just revise for now from our textbooks. Let us gather the information and let me know about the areas that are still of challenge from Meson African motifs till we meet again.